Greetings and welcome. My name is Aaron Craig with Let's Learn This Together. And this tutorial is going to be a little bit different than my other ones, which you can probably already tell by the length. So this is the project we're going to make. It is a top-down 2.5D platformer with tile collisions and object collisions. So you can see here that you can walk in front, you can go behind for both of these things, and you can move up and jump, and then you can fall off, and now you're on the ground and you can't jump up to them. You can move underneath these ones, and same thing, you can jump up. All of that you would expect from a platformer, but in a 2.5D style. Now the reason this is going to be just a longer video is because it's really difficult for me to find natural breaks in this tutorial. There's just so much that's connected, and I need to explain it all building upon itself, that I'm just going to have it be one very long video. The project will be available to download, so if you just want to tear apart my code and my project to use in your own game, go for it. You don't have to credit me. A lot of this I've just worked on over a long period of time, worked out exactly how to do it. It is not perfect. There are issues with it, so if you're going to put it in your own game, you're going to have to do some work. But I tried to leave lots of comments and make it as accessible as possible, and this video is just trying to explain what I went through, what I discovered along the way, because there was a lot that I had to discover, and dissect that and give it to you in a way that then you can replicate and build your own system or modify mine if you want to. So without further ado, let's go ahead and dive in. This is an empty project except for the camera object, which I've added. I don't want to cover all of this stuff because I have a long form series that covers how to do custom cameras, but this is it. If you need it, you can pause right here, copy the code. All I did was create a custom camera that we're going to use to follow the player, because in our game, we're actually going to be jumping based on a Z axis, not on the normal Y. And when we jump without a custom camera, it's not going to follow us up. It's going to look weird, and if you get too high on the Z axis, your player will actually completely disappear without a custom camera here. So here's the code for it, and that's all I want to say about it. It's already in my room, so I don't need to place it there. Now, the first thing we got to talk about is the sprites we're going to use. So I'm going to go ahead and right-click and create a couple of sprites. I'm going to call this SPR player. I'm going to duplicate it and call this SPR solid. Now, on this sprite, we need to resize this. I'm going to change this so it's not a 64 by 64. Instead, it's going to be 24 by 36, and then we need to actually draw it a very specific way. So we're going to put the origin down here in the middle, and it'll make more sense once we actually draw it. So let's go ahead and do that. I'm going to click on this blue, I'm going to fill this in, and then I'm going to take a fill rectangle, choose a different blue, and then at the halfway point, which would be 12 or 18 since it's height of 36, I'm going to make this a darker blue. Now, the thing that I discovered, which confused me for most of the time, is when you're doing this, you must have specific sprites that are designed for top-down 2.5D. You cannot just use regular sprites, because this is a 3D world that you're only seeing from a certain perspective. And that means you need to have sprites like this that has a clear front. So this blue right here is the front of the sprite, and this is the top of the sprite, and then you can imagine that it extends and that there's more to it in a three-dimensional space. So we are actually going to be doing most of our collision checks based on this portion of our sprite. So what that means is we want our origin to be essentially right in the middle of what would be the front of our player. So this is that right there. Let's go ahead and open up the solid and do the same thing. Now the solid can be a different size. I'm actually going to make this 32 by 32. Then we're going to put this sprite, also the origin will be in the middle bottom, but first we'll go ahead and make it. We're going to do a dark red, and then we want a darker red, so I'm just going to go ahead and click on this. I'll make it darker, and then we're going to go to 16, which is right here, and fill that in. So this is the same idea. Top, front, origin right in the middle, or at least as close to it as you can. This is going to make a big difference on how we calculate everything and how we collide with everything. So your sprites must have this kind of aspect ratio. And that's why I'm using these custom built sprites that we're drawing right here, because finding your own is actually pretty hard. There's not a lot out there for top-down 2.5D platformers. Otherwise, I would have used nicer looking sprites, but this part is important and something that I just did not figure out until closer to the end after I had a lot of it working and little things kept making issues. I figured out this is very, very important, which is why I keep talking about it. Then we're going to make 2 more sprites, and these are going to be the shadows. So I'm going to do SPR player shadow, duplicate this, SPR solid shadow. We're going to have objects that can float up, and we need to indicate that they are floating up the z-axis, not just like up the y-axis, which would still be on the ground. And we're going to indicate that with a shadow. So the player shadow is going to be essentially the exact same size. So come in here, 24 by 36. And we're going to create just a small shadow at the bottom. So I'm going to grab this gray. I'm going to make it semi-transparent, fill in, and we're just going to put it right down here. Now we're going to take the origin and again, put it right there in the middle. Now we go to SPR solid shadow and we're going to do the same thing. So 32 by 32, come here. That gray disappeared, it's unfortunate. We'll grab a different one and down here with the rectangle tool and move the custom origin. Okay. Those are all the sprites that we're going to need for right now. The other one that we're going to throw in eventually is the tile set when we start doing tile collisions, because I want to tackle that as well. Now let's make the objects for these 2. So we're going to do obj player and assign the player sprite to them. And we're going to do obj solid and assign that sprite to the solid. Now let's go ahead and set up the player. I'm not going to take the time to show you how to set up a movement system. I'm just going to copy what I have, except where it does differ. Then I'll take the time to explain what we're doing. So this is going to be the player data. Now we're going to have 3 ways of movement. So the goal here is to figure out how fast we're moving, say which way we're going to move, and then check to see if there is a collision in that spot. So you've probably seen this system before with an X speed, a Y speed, and then a while loop checking collisions. We're going to be doing that, but now we're also going to add in a Z speed because we can go up and down, and essentially we have 3 axes to work with here, not just 1. So because we have jumping, we're going to have regular move speed. We're going to have a jump speed be a negative 3.5, and the game gravity equals 0.25. That all kind of makes sense, and you've probably seen this before, so I'm not going to dive into that. This, however, is going to be specifically for the z-axis. So the z is going to be where we're at on the axis. The z height is going to be the height of our sprite's collision mask. So remember, we set this up so half the sprite is actually the front of what we're looking at, which means that's what we actually want to collide with. We imagine the sprite is standing up on the z-axis, so when we collide with it, we're only checking that darker portion. So we can do that by just saying negative sprite height divided by 2, which I did not spell sprite correctly at all. So sprite height, negative sprite height divided by 2 will get us exactly what we want. That way if you change this sprite, this will still work. Then we have Z floor, which is where we're landing. So when we jump up, we're going to change our Z, but we also need to check to see the bottom that we can land on. And this is going to be useful for where we place the shadow at, because if we're high up in the sky and we're jumping between places, the Z floor is going to change whether we're hovering over something in the air or we're going to go all the way back down to the bottom. By default, we're going to start it at 0 as well. And that's everything we need inside of here for object collisions, which is what we're going to tackle first. Later on, we'll come in and we'll do tile collisions, which will come in and we'll add some data inside of here. Now let's go ahead and add a step event. And I'm going to paste inside of here what I already have so you can see it. I've got controls as local variables for WASD. I've got checking to see if I'm pressing any of those controls, and then I'm changing my X and my Y speed. And then I'm checking to see if we are not pressing up or down, left or right, and we stop moving. Super basic, simple stuff. The last thing in here to actually make it work so that we move is going to be the move us along those. So we add our x speed to our x and our y speed to our y. Eventually we're also going to need to add our z speed to our z axis. So I'm just going to go ahead and put that in right here. Now in our room, I'm going to throw our object in here. We're going to have a custom camera, which we already do. So I think this should already all be set up and working. The only thing I think we're going to need is in the OBJ player, we need to add a begin step. And then I'm going to copy and paste this in. Again, all of this code you can find on my long form series on cameras and using them all over and for lots of different things. So this is exactly what that code is, just to follow the player, and that's all we need to do right here. Okay, I can move, camera follows me. Perfect. So we have a moving player, and that's all we need to do right now. Just want to make sure I didn't mess up any of that basic code before we jump into the more complex stuff. Now let's come down here and let's tackle jumping. I'm going to go ahead and full screen this. So you're probably familiar with jumping, and when they press jump, you change their Y speed, and then when they're in the air, you add gravity to them, and so on. And that's what jumping normally is, and that's actually what it's going to be here. The only difference is instead of doing the Y speed, we're going to put everything on the Z speed, and when we move the player, we're actually just going to draw them at a moved place instead of actually moving them up. Because we're not moving along the y-axis, we're moving along the z-axis, and that means something just a few pixels up along the y, we're not actually colliding with because we're jumping straight up. So we have to wrap our minds around those three axes. So I'm going to say if jump and z-speed is equal to 0, then z-speed equals to jump speed. And now we can start moving. So now then we've got gravity. So if z doesn't equal our z floor, so we are changing our z, we're going to add our game gravity to our z speed. So remember, jump speed is negative, this is positive, it's going to eventually bring us back down. Then when we are close to the ground, we're going to check to see if we're going to go through the floor, and if we are, we're going to stop right there. So if z plus our z speed is greater than our z floor, z speed is going to be equal to 0, and z will be equal to z floor. Now this is not going to work without adding in the draw event that we're going to need, because what we're actually going to be doing is drawing our sprite instead of moving them. So when we jump, we're going to draw it at a different spot. So we're going to take over drawing completely. I'm going to add this into the player event here. And what we're going to do is we're going to draw ourselves. So we're going to say draw sprite, and we're going to draw ourselves. We're going to draw the first image. So if you have an animated player, you'll need to actually take care of this image index increasing. And then we're going to say x, y plus our z. And then we also want to draw our shadow. So this is going to be our shadow, draw, sprite, SPR player shadow, 0x, y plus z floor. So this is always going to be that z floor so we can see when we're above things. Now when we do this, we should be able to come in here and we can jump. You can see our camera follows us. If we move around, our shadow goes up and down, left and right. And now we can visually see that we are above. Now our character is technically still down here because we're just drawing them up. But that's okay, because then we're going to check all of the collisions based on our z and our z speed, not of where we actually are at. So now let's return to our step event. And now it's time to actually set up the collisions that we need here. So I'm going to say collisions, and if this is where we're going to create a custom script. So you're used to using place meeting, or you probably are, but we are going to make a script called place meeting 3D. And it's going to take the same arguments and work exactly the same. So we can pass in our x coordinate, which is x plus our x speed, our y, and whatever we're looking for, which is obj solid. And then if we are meeting there, then we can say same thing as we normally do, which is while we're not meeting at that spot, 1 pixel away from where we're moving, then we move 1 pixel at a time. So x plus equals the sine of our x speed. And when we're done there, we set our x speed equal to 0. And we do the same thing for our y. So I'm going to copy this, put this here, and then instead of x plus our x speed, we need to come in here and say y plus our y speed. And get rid of this portion and replace it with plus the sine of our y speed. And we do y plus equal the sine of y speed and set y speed equal to 0. And that is the normal collisions that will work exactly the way you'd expect, but in 3D space. So now let's go ahead and jump into that script that we need to make. So I'm going to create a new script called collisions, because we're going to have several inside of here, including the tile collisions we do. This one's going to be called place meeting 3D. It's going to take our new x coordinate, our new y, and the solid object we're looking for. And we can use constants and built-in variables as arguments names, which is pretty cool. I wouldn't recommend doing it all the time, but here I'm not going to be using the built-in variable solid for anything, so I feel just fine overriding that. So the first thing we're going to do is create a local variable called block and set it equal to instance place, new x, new y, and our solid. Now, if you're not familiar with instance place, this is actually going to return a real number or the keyword no one. So if there is a collision, we have a number, and if there's not, then it returns no one. So we can use that to check to see, we don't care what solid we're colliding with, we just need to know if there is a collision specifically with a block and what we're looking for. If our block is equal to no one, we're going to add some more in there in just a second, but if that or some other cases, then we're just going to return false. But if we make it all the way through there, we'll return true that there is a collision. So block gets to see if there's an XY collision. If there's none there, then we're not going to have any collision at all. But we also need to check to see the actual z-axis. So if there's no block, or we're going to add some parentheses here because we're going to check two things. We're going to check to see if our z is less than or equal to block.z. So we have to have block be equal to something, which is why we're checking that it's not. So if this is true, then this is just going to return false immediately. But if this is false, then our if statement will come and check over here, and then we actually have a block to check this against. So if we're underneath the block and we're jumping up and colliding with it, or our z height is greater than or equal to that block.z, so we're underneath it, so we don't need to worry about it, or we are above it and we don't need to worry about it right now, then we are not colliding with it. And this is all the code we're going to need inside of here. To test this out, our block needs to have a z. So let's open up our obj solid and add a create event. So we need to add in a z variable here. Now, this is also one of the most confusing things that took me forever to figure out, and I want to have you avoid that trouble. Z cannot just be any value here. It has to be half the size of our sprite. So if I set z equal to -16, that is half the size of our 32 by 32. And then it's actually going to work because the collisions we're looking for, remember, are only right here or right here. We're only looking at the top half when we're colliding on these, so we can run right into this. Now, this part is essential. If you have a sprite of a different size, you must then change the z. I'm going to show you that as we go along. I'm going to stretch this out. We'll have larger blocks and solids, and then we'll change the z accordingly. But this is essential that it be half the size of your sprite. Otherwise, the collisions will work, but they'll be completely off and in the wrong place, and you might be hovering in midair or colliding with something that doesn't even look like it's there. So remember that must be half the size of the sprite. And I comment that very thoroughly in the project if you downloaded it. Okay, let's try that. Throw our blocks in here and run this. Now, it's not going to be hovering or anything yet, but if we run into it, we now have a collision with it. Now, the collision is actually working all the way here, and you can't even get closer, and that's because the sprites, we've set these here, but we need to actually set the collision masks to also be that. So let's go to manual, and let's set the collision masks to now be the front of the sprite that we have. If we do this, and we run it, now we'll be able to collide with it in a way that looks a lot nicer. That is, at least for the back, because we don't have a good depth system yet. Now, there are tutorials on full depth sorting systems for a game like this. I'm going to take the easier route, and I'm just going to open up our player, and I am going to go to the draw event, and I'm just going to say depth equals negative b-box bottom plus z times 2. And then I'm going to grab this, go into our solid, and I'm going to place it here, but take out the times 2 portion. Now if we run this, our depth system is going to work fairly well. So we can move in front of it, and then we can move behind it. Now this will start to break down if you have more complex interactions, things floating, jumping, falling, all of that. But this is a really good starter system, and it allows you to do that. Now you can see that we don't have collisions underneath us yet, because we only have our X and Y collisions. So let's go ahead and set that up next. Inside of OBJ player, let's go back to the step event. So these are the X and Y. We've done those, that makes sense. Now what we have to do is do a Z check underneath us for if we're going to be on something. So underneath our collisions, what we actually need to update is our Z floor, because our snapping and our gravity are all checking against Z floor, which is where we're going to land when we fall. So we're going to do Z floor snapping. And this is how we're going to write this. If we are colliding with an OBJ solid where we are. So remember, in the game, when we jump, we actually are drawing our sprite up here, but we're still down here in the collision zone. So if we are colliding with something, and even though we might be above it, that we know that, so we can use that information to say, if we are colliding with it, then we need to update our Z floor. We're going to get exactly what we're colliding with by saying var block equals instance place xy obj solid. And then if we're higher than it, we're going to say if block.z is greater than or equal to rz, then z floor is going to be equal to that block. So we get the top of the block, and that's where we're going to stop. If we're not colliding with anything, then our z floor is going to be equal to 0. And that's all we have to do for that. So we check to see if we're colliding with something, because remember, when we jump, we don't actually jump, we don't actually move our x and y, so we can still be colliding with it. So if we jump up now, we are colliding, but we know that, and so we stay right above it, and our place 3D checking is coming out clear because we're above the object, and that's fine. So now we can jump, we can fall off it on the back, we can fall off it on the side, and we can fall off it on the front. Now, the thing you might notice is when you're moving front, it might kind of look like you're on nothing here, but remember, we're checking this collision mask because this is kind of the front, this is the top, and when you're on it still makes sense right there. As soon as you fall off, you're no longer on it. Now, I want to show you what happens if we adjust our Z or we change it to any other value. This is going to mess up all of our checks in lots of different ways. So now it's actually, we can't even collide with it at all because all of our collisions are based on that Z check. And then if you don't set your collision mask to where it's supposed to be, this is also going to mess up your collisions, but in a different kind of way. So we can jump on this, but now all of a sudden we're floating and it doesn't look good. And we fall off all the way up there, even though we still fall off right about there. So all of these things must be exactly like this, otherwise you're going to run into a lot of different problems. Now let's tackle floating solids so that we can actually put them up in the air. So in OBJ solid, we're going to add a draw event. We're going to do kind of the same thing we did for the player. It's actually going to be floating up higher, and we're going to draw that. So let's go ahead and draw self and the shadow. So the first thing we'll draw is the shadow. And we don't need a shadow if we're at -16. So we're going to check to see if our z is not equal to -16, then we draw our shadow sprite. Because if it is -16, that means we're on the ground. We don't need to worry about that at all. So we're going to do SPR solid shadow. And this is just going to be where we're at. So X, and then we're going to specifically use Y start. So the system I have here does not work for moving objects. If that's something you want to do, you'll need to actually put a variable inside of here and figure out where to draw the shadow at as your object moves, because we're going to do something in a moment here that moves the object, the solid, after the game starts, but only one time. So we need to remember where we started the object at, and that's where we're going to draw the sprite if we need to. Now we're going to draw self, but inside here, if we are moving, which we are going to do, we actually want to make sure we adjust our depth. So I'm going to take this out of our create event and put this here, and then I'm going to draw sprite extended this time, because we're going to come into our room, and I'm going to add like one of these here, and then I'm going to be able to grow this. And now we have a much larger sprite, but we need to continue drawing it the correct way. And the correct way can be using this function by taking into account our image X and Y scale, which is what we're going to do. So we're drawing our sprite 0, X, Y start plus our Z, so how much we've gone up. And then we're going to take into account our scales. The rotation is going to be 0, C white, and 1 for alpha. So we're not messing up anything here at the end. We just need to account for our image X and Y scale. Otherwise, it's not going to look very good. Now back in the create event, I'm going to set alarm 0 equal to 1. Then I'm going to add that event. And all we're going to do here is say Y plus equal Z. And so this will move our solid up the amount that our Z is. So that means for any objects that are of different sizes, we need to open them up, like in this, and edit the creation code. And our image X scale here is 2 and 2. So we're just going to say Z equals -32. Now, this now has a drop shadow, which granted needs to be fixed. Let's go ahead and come into the solid, and we're going to say draw sprite extended here as well. And we're going to take into account our image scales, and that should make it look much better. Let's give that a shot. There we go. So now we have this object that's a lot higher up, and we can walk underneath it, and we can jump right through it for now because we don't have a collision when we're jumping up, but we'll set that up in a minute. And we can jump on this as well. So this looks really weird though, like jumping all the way up here. And that's because where you place these objects in the room matter a lot. So even though we want this object to be floating, we want it to be down here when it starts so that it's about at the same spot. And then we're going to take care of it floating in code. So this is where it needs to be to then look like we can access it right there. So now it's on the same plane and we can hit it. And it functions exactly as you would expect. And so that's the system we're using here. If you want to add more blocks, you can change their size. I experimented around with coming up with a way of getting these blocks to be this size and change their Z and adding like a Z height, like kind of like we have for the player. I know there's a way to do that. That was a little bit beyond what I was able to discover here. So if you want to have higher up blocks, you are going to have to just change their size, and then you can have them up higher by changing their Z as well. So we can set the Z equal to -48 here. And now this block is going to be up much higher as well for us to jump on. So you can see we actually have to move up. And because of that, we have to make sure we place it in the right area, which is right here. And then that will work correctly. So if you come up with a better system to be able to do this and have them all be the same size, but put them anywhere on the map, definitely let me know. I would love to see that and add maybe a follow-up video to this tutorial. But now let's jump back into our collision code here. There's a quick thing we can do to just update our depth. So when we do have a collision, so we're going to just say we can update depth right here. If block, so if there is a collision, and block.z is less than rz, depth equals negative b box bottom. So in this case, we don't want to appear inside of that block when we're actually underneath it. This little code snippet here will make it so when we walk underneath, it changes to when we're underneath it now. So that's pretty cool. Next, let's add in a quick check to see if we are jumping and colliding with a block that is above us, because right now we just go right through them, which isn't exactly ideal. So down here, we're going to say collide with bottom of block. And it's going to be very similar to what we just did in the Z floor snapping. So if instance place xy obj solid, var block, we get that. But this time we're going to say if block and block.z is greater than rz plus z speed, and, oh, I did not spell block right over here, and our z floor is greater than or equal to block.z. So we're making sure we're underneath the block. Then we want to do a quick check that we're not above this block in any form of way, like with our z speed where we're moving and such. So we're going to say if z speed is less than or equal to 0 and z block.z is, or z is greater than block.z, then we just set our z speed equal to game gravity. So if we're moving up, which is what we would be doing here, if our z speed is less than 0 because we're moving up, then we're just going to say set it equal to a positive number, so it's like you hit it and then you come right back down. I have one too many parenthetical marks on that line, and this will stop us from colliding with that block now. To check it out, we're going to go in and we're going to change our jump speed to 6.5 because we can't really tell with our negative 3.5. So now we can jump super high, but if we come in here, we hit it and we fall back down immediately. Now we can jump right here because we're in front of the block. And right here, it even looks like we are underneath it, but we're not quite. This is one of the glitches that I just haven't been able to fix with the depth system because I didn't want to put that much time into creating an entire perfect depth sorting system here. But again, you can find lots of those videos on here, YouTube, for free, and you can apply them to what we've got right here. So I'm going to put down our jumping, and now that code is working exactly as we would expect. And this is actually a really great place to end this video. In the next one, I'm going to take what we've got here and throw in tile collisions. So I'm going to add an auto-tiled tile set into our project that we can create on different tile layers and have it be a collision based on those tiles. So again, it's going to look like this. So this is a tile that is auto-tiled at the first one, so it's at -16. The next one's at -32, and then at -48. And you can see that we can jump onto each one. We can't jump onto that one because it's too high. Same for this, but we can jump onto that one. We'll be able to move behind these tiles, and we'll be able to have these collisions set up basically automatically with our auto tiling, which is really cool, really powerful, and probably the most useful part of this because, well, when you're doing collisions in a top-down platformer, they're probably going to be tiles. So this is what will make it really easy to do that. Stick around for my next video when I cover that. But if you enjoyed this, please leave a like. It lets me know that this content is appreciated and helps me to continue making more. But as I always say, keep making, keep learning, and I'll talk to you later. A huge thank you to all of the awesome people who support me over on Patreon. Their names are on the screen now, and every dollar pledged helps me create more awesome content. You can support me for as little as $1 a month and get access to exclusive perks like my Discord server, your name in the credits, early access to my YouTube videos and courses, and more. Check it out at patreon.com/letslearnthistogether.com or find the link in the description below and become a patron today.